Okay guys, so let's begin this video. This is 11.5, worksheet number 6. This is the 12 o'clock class here. And I know we've been talking about probability, and so it's going to get a little bit more involved in this section. We got more events happening. Last time we did talk about 2 events, but we did kind of a basic introduction to it. So now we're going to talk about having 2 or more events and how to calculate the probability for that. Okay, so let's get started with the formula, okay, right at the top. So the probability of event A and event B, so first A and then event B happening, is going to be the probability of event A times the probability of event B. Okay, that's the formula. So this is a multiplication formula, and you'll see the difference between the other formula I'm going to give you today. All right, and so this is 2 events, 2 separate events. And we're going to assume that event A has already occurred. Okay, it's already occurred. So if you remember from last time, we had a couple events and talked about with replacement, without replacement. So the first event affected the second event. And that's the same thing we're going to talk about today. All right. Now, number 1. It says, so probability of 2 or more events, that's very important, versus just 1 event that we're going to talk about on the next page. So this is given a jar with 5 red, 6 blue, and 9 white marbles. What is the probability of... Now, I don't know what this is doing here. I don't think you have this, right? This little weird... Anyways, let's ignore that. But what is the probability of... Remember, we're gonna grab twice. Now, are we going to replace the marble or not? Well, it says with replacement. So we're gonna grab a red marble. What are the chances of grabbing a red marble and then actually grabbing a blue marble? Okay, so first, this is what we always do first. We need the total. Why do we need the total? We need the total in the jar. That's going to always go in the denominator. So what's the total here, guys? 20. There's 20 marbles total. So if you grab a red marble, how many are those there in the bag? There's 5 red marbles out of 20. And then we're going to replace it. We're putting it back into the jar, so we still have 20. Okay, so the second event has 20 total. But how many blue marbles are there? 6. So that's basically your calculation there. Now, let's talk about this calculation. Now, if you don't have a calculator, typically what you're supposed to do is go straight across the top and straight across the bottom. Right? So if you did that in your calculator, you would get 30 over 400. Okay? Now, there is a way to do smaller fractions if you reduce first. But guys, we all have calculators. You can use calculators on the test. So there's really no need to talk about reducing and strategies for that. Some classes, you have to do this without a calculator. But since we do have calculators, guys, we can just type. You have to find the calculator button, because if you don't, it will give you a decimal. It's okay if it gives you a decimal. You're going to have to convert it with a converter button that you have to find and know how to use. Okay, so for my calculator, which is a TI-30X, I can just do, the fraction bar is up here. It says A big A and then lowercase b slash c. It's like a mixed number. So I'm going to do 5 fraction bar 20 times 6 fraction bar 20. I just press equals, and it reduces it, just gives me the answer. Okay, which is what? 3 over 4, 40. If I didn't have this, well, I can reduce the 30 over 400, right, by dividing by 10. So, I mean, you can do it like this, but you don't really have to waste your time doing that. I mean, that's up to you, okay? Now, what if you don't have a nice calculator that does the fraction stuff? Hopefully it has a converter button. What I mean is, you can do 30 divided by 400, get a decimal. I got 0.075. So now I can look for a converter button, converts it to a fraction, so I have to click second, and then I click, hold on, wrong one. And then it gives me the 3 over 40. Okay? So either way, you have to learn your calculator. Now, if you have a phone, it's not going to be as nice as this. So what you can do, guys, is download if you're just using your phone just for learning purposes, you can download a calculator that does fractions. You have to kind of look for it, write the word fraction in your search. Or you can do a Google search, fraction calculator, and Google will kind of do it on their webpage instead of you downloading something. So it's up to you. Okay? But just remember, you cannot use your phone on a test, so you have to know how to work some type of calculator. Okay? I do give you guys calculators if you forget yours, so you'll have to probably learn how to use that one. All right, any questions about the calculator or the fraction part here? Okay. All right, let's try letter B, which has 3 events. Okay, so letter B has you picking a blue marble. How many blue marbles do we have? 6. Now, we're also going to put it back into the jar. That's called with replacement. So we still are going to have 20 on the next grab. So how many blue marbles do we have this time? Has it changed? No, still the same. Now, if it would have said without replacement, that means you have a blue marble in your hand. It's not in the jar, so you would have 5. But in this case, it's the same exact amount. How about the white marbles? 9. So as you can see, guys, if you don't have a calculator and you're doing this by hand, it's not going to be very nice. I think this is fun. I mean, you can break it down, you can simplify it first, you can do prime factors all over the place and start canceling stuff out without a calculator. But you guys should have calculators, so just type and press and get your answer, okay? If you think that's if your calculator is not very effective with that, you can just type in these 3, all right? That'll be 324. And then type in the 20 times 20 times 20, that'll be 8,000. So technically you will have the right answer, it's just not simplified or reduced. Okay? So what's the reduced form of that? Don't try to do this in your head, guys. You got to use your calculator. All right, or look at the answer key in the back, right? So it says 81 over 2,000. Okay. I'm not really going to test you on your fraction abilities. I'm more testing you on can you set up the probabilities of each event and deal with that with your calculator, okay? Okay, so I'm going to go ahead and finish these 2, and then I'll let you guys try number 2. So what happens, guys, we do the same exact ones, A and B, but without replacement. That means once we pick the first one, we're not going to put it back in the jar. Okay, how is that going to affect it? So let's take a look. So without replacement, let's go back to A. We're going to pick a red marble. That's the same. And then when we pick that blue marble, we still have 6 blue marbles because we didn't grab a red marble, a blue marble. We grabbed the red one. But how many total are in there now? 19. So you see how slightly different, but that's definitely going to change your fraction. Okay. So if you're doing this straight across the top, I'm just going to write these. You don't have to write this fraction if you don't want. You can go straight to the answer. Okay. So look at the difference. You have 3 over 40 right here versus 3 over 38. Okay, it's just a slight difference. Slight difference. Okay, what about D? Okay, let's do this guy right here, but with replacing without replacing the marbles. The first one's going to be the same, 6 out of 20. So that's 6 blue balls. Now, marbles. If I take out if I have a blue marble in my hand and I'm picking again, how many blue marbles do I have? 5. And I have 1 less total. Okay? So look at the difference. It was 6 out of 20, 6 out of 20. Now it's 6 out of 25 out of 19. Okay? We have 1 less. So what about the white marble? Yeah, the 9 is going to be the same, but how many marbles total do we have? We took 2 out. So now it's 18. So as you can see, the fractions get kind of crazy here. So type this on your calculator and get the final answer simplified. But if you did this by hand, 6 times 5 times 9 is this, and then 13,800. And you get this, okay? Okay, so let's do number 2 with your partners, letters A and B right here. And we'll see how you do. All right, so this is supposed to be 3 out of 76. That's correct. So I just gave you the answer for the next one. All right, let's get back going with the next problems. I want to do number 3 with you, and then you can do 4 and 5 in your group. So we have a cooler which contains 4 root beers, 8 Sprites, 3 Cokes, 5 Mountain Dews. If 3 drinks are selected in succession, what is the probability that, okay, number 3 says the first is Sprite, the second is Coke, third is another Sprite with replacement. So you may see, if you click on, help me solve this, you may see the symbolism behind this. So I just want to write this down. I'm not going to do it every time, but basically this is the probability of the first event, which is picking a Sprite, times the probability of the second event, which is picking a Coke, times the probability of the third event, we're just picking another Sprite, and this is all with replacement. That means that our total will stay the same in the denominator. And how many total are there? 20, yep. So that means it's 20 here, 20 here, 20 here, okay? So how many Sprites? It's right there. That's 8. Coke is right here. And Sprite is 8 as well. So this is pretty straightforward because it's with replacement. Did it work out for you?
Yeah, I did.
Okay, great.
Did you change something?
Okay, so guys, this is one, if you're doing it this way, it's 192 over 8,000, which reduces to 3 over 125. Now, let me just interpret this a little bit. Remember when we first started talking about probability, I started to say, well, that's great. This is the answer. But in terms of visualizing the percentage, what are the chances of this actually happening in real life? Okay, if you replicated this scenario and did this experiment, so if I do 3 divided by 125, I'm going to get 0.024, which in percentage is 2.4%. What this is saying, the translation is, I have a 2.4% chance, if I did this little game or scenario, I would, to get a Sprite first, a Coke second, and a Sprite third, all with replacement, I have a 2.4 chance of that actually happening. Okay? Very, very unlikely. You have a 97.6% chance of it not happening. So I would not, wager anything or bet your life on it or nothing like that, because it's most likely not going to happen. Okay. Now, if you were giving out a prize, if you had a bunch of prizes you wanted to give out, and you said, okay, whoever picks, you want it to be very small because you don't want to give away all your prizes, so you want to say, okay, whoever picks this out in that particular order, Sprite, Coke, Sprite, is going to win a prize. Okay? And if you had 100 people do it, most likely you're going to have only 2 win. That's what that's saying. Okay? So you won't be spending your whole budget on prizes. All right. So sometimes visualizing the probability with a percentage can be helpful. All right, guys, go ahead and do the next 2 in your group if you haven't done so already. So the first page was 2 more events. Now we have the second page where we're going to talk about one event. Although it kind of looks like there's more than one event. And it's not actually more than one event. It's actually varying characteristics. Okay, it's not really separate things happening. They're sharing characteristics with each other. Okay, just if you look at the diagram, you have ones and 1 through 4 basically, but you have multiple ones because they're shared with rectangles and circles. Okay, so it's impossible for a rectangle and circle to have anything shared in and of themselves, but once you label them with a 1, now they say, okay, well, now we share a 1. Okay? Or, for example, 2 and 3, they share nothing, but once you put them both in a rectangle, now they both have a rectangle characteristic share. So let me go ahead and give you the visualization of basically the two types of calculations you can do. So the first one is basically, okay, what if they share nothing in common? So you remember when we talked about sets? Logic, sorry. Logic. Two things may not have anything in common. So let's say these two are two non-shared characteristics. And that's very layman terms without using any fancy math words. Now, because I do want to introduce, something called mutually exclusive. These two characteristics are mutually exclusive in and of themselves. That's like a circle and a rectangle. There's nothing about them that you can put together. Okay? Or a boy and a girl, or red and blue. Okay? Just can't. They cannot happen at the same time. So, if you pick a card from a deck, you only have two colors. You have red and black. So I can't say, hey, what's the probability of choosing a black and a red at the same time? I can only pick one card. That doesn't make sense. So it's zero. Zero chance of doing that. These are two separate events. Okay? Now, the calculation for that type of scenario, guys, will be just addition. That's what we were working on in the previous sections. Okay? You just add them. You just straight up add them. Okay? Add them up. Probability to the first plus probability to the second. But it gets, a little bit tricky when you have shared characteristics. So if you have shared characteristics, then it's overlapping. Okay? And that means we're going to actually start double counting. Okay, so we have to be careful. We can't just add these two up because we're going to double count whatever they share. So to correct that, we have to do some subtraction. All right? So yes, we are going to add them up, same as before. But to make sure we don't double count this overlap, we have to subtract what they both have in common. So I'm going to put, this is the technical way to put it, but I'm going to be using the word both. Okay? They both happen at the same time. They're both shared. Okay, so let's take a look at this scenario. Okay, we have some cards here. Rectangles, circles. First, what's the first thing you always do? You need that denominator, which is the total. So how many? 16 total cards. Okay. And we have some shared characteristics. So we have odd over here, we have even over here, there's a bunch of twos. The row of threes is all odd, and the fours are all even as well. Okay? All right. So here we go, guys. One shape above is drawn. So there's the key phrase there. So although this looks like it's two separate things happening, and you may be tempted to multiply like we just did, you have to remember that's for two events. This is one event. It's only one. I'm going to grab once. What are the chances that whatever you just grabbed is both odd and a rectangle? Okay? So you can actually just look up there and count them. Right? This is both. So basically you're just going to do both odd and rectangle divided by the total. So we already know the total is 16. How many are both odd and rectangle? $100. Yeah. So rectangle, that's these guys, and the odds will be 1, 2, 3, 4. Okay? So that means you have 4 that meet both criteria at the same time. They're odd and they're rectangle. Okay? So it's not the multiplication that we just talked about on the page 1. All right, so now this reduces to, divide both by 4, you get 1/4. Okay? Now, we actually need that calculation because guess what you're going to have to insert over here? And by the way, this is a P. That kind of looked something like something else. But that number that we just did, or that fraction, we need that for this guy. When you see the word or, we're going to be adding and then subtracting the both. All right? So now we have 3 fractions to do for the next one. The next one says or an even card or a rectangle. Okay? So remember, we have to add them up, but we have to subtract because we're double counting since they're shared characteristics. So you may see this when you're clicking on help me solve this. You may see probability of the even plus probability of the rectangle plus minus my bad minus whatever those two share. So we're going to put probability of both happening at the same time. Okay. So probability of even. How many even numbers are here total? Four here. 4 here. That's 8 even numbers total. 8 out of 16. How many rectangles are there? Same thing, right? Whoops. So there's 4 here, 4 here. That's 8. And then minus both at the same time. So even and rectangle at both at the same time. How many of those are there? So even and rectangle. So here's an even rectangle, even rectangle, even rectangle, even rectangle. That's 4. Okay. So since these all have the common denominator, you don't have to mess with that. You just have to just go ahead and calculate the numerators, the top. So 8 plus 8 is 16. 16 minus 4 is 12 out of 16. Now you can do your calculator, also can help you out with that because it'll reduce it automatically, which is 3/4. Okay. 3/4. So what I want you to do in your group, something happened here. Anyways, all right. I want you to do numbers 8 and 9 in your group. Yes. Counting the evens and the rectangles at the same time. It's an even. When I pull a card, that card is an even number and a rectangle.
So that makes it 8.
So I have have two even rows, right? These are even rows. And if I focus on the rectangles, it's only, I'm going to skip the circles. So it's that, those twos, and these, those are even and rectangles. There's four of them. And that's going to go right here. Because here, I've already counted those. Actually, I'm counting them twice. So I have to pull it out, so I'm not double counting. And that's what this minus is. It's taking out the intersection of it. Now, if they had nothing in common, then we don't have to do that. But, yeah.
So, where does the minus come from again?
It's part of the formula. So if I okay, so where's it at? Even. Okay, so evens are right here, right? And then rectangles are right here, right? But notice that I just counted, I just touched with my pen, I touched these four in both cases. I counted them in the, when I looked at the evens, I counted those twos and those fours. And when I went down on the rectangles, I counted them again. So we're not supposed to be adding stuff up twice. Like we're repeating it, we're not supposed to. So the subtraction is there to make sure you don't double count. Okay. So there's two in here that I'm going to count twice, and two in here I'm counting twice. So I'm taking those four out. So I don't count twice. But that's just part of the formula, guys. It's plus and then minus. Plus each individual one, and then minus the both, because something happened to my screen. Let me just do number 10, okay? And then you can do 11 on your own. Okay, number 10. You have 10 small pieces of paper labeled 1 through 10. And you're going to put them in a hat. Okay, so we know the total. And you're going to do one event. You're going to pick one from the hat. This could be to go first and to do something, or pick a team, or pick who's going to win the prize, or whatever. So it says even number or greater than 6. Okay, so you're going to do the probability of each of those separately. And then you're going to do minus both. Those two events happening at the same time. All right. So how many even numbers are there from 1 to 10, guys? I mean, you can count them. Yeah. It's 2, 4, 6, 8, 10. That's 5 evens. How many greater than 6? Seven, 8, 9, 10. 4. So that's 9 total so far, 9 out of 10. But we have to subtract, we just double counted some that were even and greater than 10 at the same time. So what two numbers, okay, so what two numbers are greater than 6 and they're even? 7 and 9. No. 8 and 10. 8 and 10. That's odd. That's okay. I had to learn this one. 5 and 5, something like that. Right? Par y sin par. Oh, impar. Okay. Yeah, I had to look that one up when I was in my early days. Like, okay, how do I translate this? 'Cause I've never heard of it. Yeah, so 8 and 10, it's greater than 6, and they're even. They're both happening at the same time. So there's 2 of those there. Okay. So 9 minus 2 is 7, and we can't reduce it, so we are done.